Hello, I'm Mina Rashvand from Iran and I hope all is well with you. I want to talk about a rapid sedimentation at Paresar intake basin located in Caspian Sea due to large wrack particles and wind-induced currents. At first, let's take a brief look at headlines. Introduction of problem and objectives is the first step. The two step is describing study area and morphological properties. Then field observation and laboratory experiments will be described, and finally simulation of sediments in DHI mic model will be explained. Okay, a case study is presented here is an unnatural wrack accumulation at the coast which combined with exciting sand and has resulted to a major increase of actual LST rate. Two effective parameters exist here. The first one is sediment properties like density, particle size, fall velocity, shields parameter and porosity, and the second one is currents, especially wind-induced currents. Objectives of this research is a study about wrack particles and the effect of wrack particles and wind-induced currents on longshore sediment transport. Paresar power station is located in southwest part of Caspian Sea, as you see in the picture. Morphological evidences based on sediment transport direction of three rivers near basin and Asra port at upstream of Paresar shows that LST direction near Paresar is from northwest to southwest. Breakwater performance shows in first 3 years sand and vegetative wrack were observed at the northwest of main breakwater, and then from July 2012 to December 2013 advancement and rapid LST at the updrift shorelines and decrease of water depths at the entrance was occurs. And finally, in March 2014, increased shoaling within the basin was reported. So, investigation on this unexpected sedimentation shows wind-induced current in Caspian Sea and wrack's movement dynamic play key roles on longshore sediment transport. Short distance from heights to beach, a slip slope of shoreline vegetation development near to shore resulted in wrack generation in west of Ilan province. Also, we have two similar cases near Paresar, and Astra beach zone and Talish beach zone. Okay, for field investigation, we choose 4 stations in beach and 1 station at the entrance of nearest river at upstream of Paresar. The samples were selected, and here you can see the details of holes. Then in laboratory we dried the samples, and then relative density of racks, sands and composition of them with a specified mass ratio were determined. In most samples, mass ratio of rack to sands was 50%. Okay, here we separated the wrack particles and equalized them by sphere shapes. Actually, samples were classified by standard pore size seals, and you can see the diagram of passing particles. Okay, now for one-dimensional modeling setup, at first initial coastline and breakwater location were defined. You can see them here. the breakwater and baseline normal to north, it was 44 degrees. Here we can see the bathymetry of a cross-shore profile and 4 zone for sediment aggregation, A1 to A4. You can see them here. The porosity of aggregation of wrack is about 50%, and for determination of fall velocity and shields parameters, we use specific formulas, and you can see them here. And shields parameters also is calculated by these formulas. Then you can see particle size distribution here. This four diagram is sand distribution, and it's wrack distribution. And finally, you can see the calculation of fall velocity and critical shields parameters, and that the maximum shields parameters that we can define in LITPACK is 0.06. Okay, for wave data is exported from Iranian seas wave modeling, ISWM. They are for 1992 until 2003. The wave dispersion here demonstrates that they predominantly came from a northwest. Here you can see they came from northwest. For current data, because we haven't any measurements current data near site, we must use a hydrodynamic model with mentioned initial boundary conditions. The wind data reference was ECMWF, and this is the properties of two-dimensional modeling. At last, the two-dimensional model was calibrated with monitoring data and astroport, as you can see here. You can see here the comparison between the simulated wind-induced currents and measurements by AVAX at astroport. There are several parameters resulted errors, for example constant roughness ratio and friction coefficients, and others. Okay, here you can see current direction and you can see current direction which is in the same direction as the wave. Here you can see it. And here comparison between current velocity distribution in one-dimensional model and two-dimensional model indicates they are closely matched together. You can see they here. The red one is a two-dimensional output, and the blue one is one-dimensional output. Okay, at last we can run our one-dimensional model by two calibration parameters: active depth and bed roughness coefficient. We can see the comparison between measured and simulated parameters here for net annual drift and beach position after 3 years. One of the other activities we done here was choosing a wave in deep water for measuring sensitivity of the model to sediment properties. You can see the wave properties here. And finally, we can see the wrack's effects on bed concentration, on bed load transport. The wrack is the rack increase the bed load transport. Here we can see the effect of racks on mean concentration and suspend load profile here. And the effect of sediment porosity on sediment transport here, the porosity of 50% and 40%. At last, I want to show two important diagrams which has been affected by combined impacts of wind-induced currents and wrack particles. The first one is annual net transport, and the second one is depths of water depths at the tip of a main breakwater. You can see them here, and the impact of racks and sands here. Okay, the conclusion is described here. We can see the high percentage of rack particles with different characteristics in comparison to sand, such as fall velocity and resuspension, play a major role in littoral drift, sediment and accumulation, and subsequent shoreline advancement. Wind-induced currents have a small effect on the rise of wave-induced longshore currents. Also, wind-induced currents has a similar effect on both sediment type, sand and racks. And generally, in the long term, both factors have similar behavior, but in short term, the effect of racks and sediment type is predominant on the accumulation rate. Thank you for your attention.